To Backspace Academy. One area of AWS that has grown rapidly over the last couple of years is that of big data. In this lecture, I'll go through the big data services that are available with AWS. I'll talk about Amazon Redshift, the data warehouse service, Amazon Elastic MapReduce, the Hadoop service, the Elasticsearch service, which provides search engine capabilities, the Amazon QuickSight, which is a relatively new service that has come in for business intelligence reporting of big data. I'll look at machine learning for predictive analysis of data and Amazon Kinesis for analysis of real-time streams. The big data services available to us in database and storage are Redshift, DynamoDB, Amazon S3, and of course RDS. In analysis, we have Elastic MapReduce, the Hadoop framework as a service. We have Elasticsearch search engine as a service, QuickSight business intelligence reporting, and Amazon Machine Learning for predictive analysis of data, and AWS Lambda for compute capacity. For analysis of real-time data, we have Kinesis Streams, and we also have third-party applications that can be launched on EC2 instances. Amazon Redshift is a petabyte scale data warehousing service, and it is based upon PostgreSQL database engine, and it's accessed with standard business intelligent reporting tools. You can still use it with Tableau or BERT or whatever you are using to collect data from a PostgreSQL database. You can still use those tools. All data is replicated between nodes in a cluster, and it is continuously backed up to Amazon S3 with snapshots, and those snapshots can be held for 1 to 35 days. As is the case with RDS, user-initiated DB snapshots are retained upon cluster deletion, and it also allows for quick recovery from those snapshots.
Now, it's one thing to have a big data warehouse, but we need to be able to get our big data that we've got already into that data warehouse. So we need to think carefully about migration of big data. The services that are available for us to use, first off there, we've got database snapshots to S3. So we could create an RDS snapshot of our database and then use that snapshot to create a replica of that database. We have the AWS database migration service, and that will allow us to transfer data from a source database through to a target database over a connection. We also have the AWS data pipeline, and that again will allow us to create a data pipeline job which can transfer and convert, if needed, data from one data source through to a target database. And finally there we have really the best solution for migrating of large amounts of data, and that is to use the AWS Snowball and use that Snowball device to import to Amazon S3. And again, like we explained in the introductory of this course, the AWS Snowball device, you can have that sent out to you on premises. You can upload your large amounts of data to that Snowball device, or devices if you've got even more than the Snowball device can handle. And then you courier that off to AWS and they will upload that for you into an S3 bucket. All you need to worry about then is getting it from your S3 bucket into your target database, and that is where the AWS data pipeline comes in. So you cannot do that with the AWS data migration service. You can't go from S3 to a database, but you can create a job in the data pipeline service to import from S3 into your database. The reason we would want to use Snowball, I've just got a table there, even when we're looking at a gigabit connection with high network utilization, to transfer 100 terabyte of data across to AWS would take 12 days. So we would want to consider using AWS Snowball when we have 60 terabytes or more of data to transfer across. When we start looking at lower quality connections that are going to take about a year to upload, certainly we want to look at using Snowball for 2 terabyte or more of data.
Elastic MapReduce is AWS's fully managed Hadoop service. Apache Hadoop, it's an open source framework for the distributed processing of large data sets across clusters of compute instances. The AWS EMR service, it provides clusters of EC2 instances that analyze our data, and those clusters can be automatically deleted upon task completion. So when the job's done, we can have those clusters terminated if that's what we want. It's not suitable for small data sets, and it's not suitable for ACID transaction requirements. The data processing frameworks available are Hadoop MapReduce and Apache Spark, which simplifies the process of creating MapReduce functions. The storage options available to us are the Hadoop Distributed File System, which is ephemeral storage, and we have the EMR file system, or EMRFS, which allows you to access Amazon S3 as a file system for Elastic MapReduce. And we also have the local file system, which is on our EC2 clusters, which is the EC2 instance store. AWS Elasticsearch is a fully managed implementation of Elastic.co's Elasticsearch framework. Elasticsearch is a real-time distributed search and analytics engine. It is the most popular enterprise search engine. It is used by Facebook, GitHub, Stack Exchange, and Quora, to name a few. So it is a very popular analytics engine and used as a popular search engine. You can analyze data from Amazon S3, Amazon Kinesis streams, DynamoDB streams, your CloudWatch logs, and CloudTrail logs. It's suitable for querying and searching large amounts of data, as is any good search engine. And it's not suitable for online transaction processing and for petabyte storage. So if you're looking for petabyte storage in an Elasticsearch framework, then you should look at managing that yourself by using an AMI and launching it on EC2 instances yourself. Amazon QuickSight is a relatively new business intelligence reporting service from AWS. Very good service. It provides very good BI software at 1/10 of the cost of traditional software such as Tableau. It provides a super fast parallel in-memory calculation engine, or SPICE. Although it says there, 1/10 of the traditional BI software. Of course, there are open source BI tools such as BERT that will cost you nothing virtually. Amazon Machine Learning is for predictive analytics and machine learning simplified with visualization tools and wizards. So it has some very, very complex machine learning algorithms behind it, and it makes it very easy to use because of the wizards and these tools that are available to visualize what you are trying to analyze. The data sources for input to AML include Amazon S3, Redshift, and RDS, or the MySQL RDS. It's very suitable to flag suspicious transactions, for forecasting product demand, for example, for personalizing application content on a website, for predicting user activity, and also for analyzing social media streams. It's not suitable for very large data sets, and it's not suitable for unsupported learning tasks. So there are a library of learning tasks, but if they're not supported by the AML, then it cannot do that. So consider using, if you need something else that has more learning tasks, then consider using Elastic MapReduce to run Spark and the machine learning library for Elastic MapReduce. Amazon Kinesis is very good for analyzing real-time data in the format of a stream. So data can be put into streams, into a Kinesis stream, using API calls, using one of the software development kits, which have Kinesis functions inside it. And also with the Amazon Kinesis Producer Library, or KPL, which is a C++ application that we can use to channel our data into Kinesis, and also the Kinesis Agent Java application as well. Once we have a Kinesis stream established, we can use the Kinesis Client Library, or KCL, to process that data in that stream. And that's available for Java, Node.js, .NET, Python, and is currently being developed, from what I understand, for Ruby. Kinesis Firehose can capture, transform, and load streaming data into Amazon Kinesis Analytics. Amazon S3, Amazon Redshift, and also the Amazon Elasticsearch service. So that allows for real-time analysis through that Kinesis or Firehose of our stream data. Kinesis obviously is suitable for real-time data analytics. It's suitable for log and data feed intake and processing, and for real-time metrics and reporting. It's not suitable for small-scale consistent throughput, and it's not suitable for long-term data storage and analytics. It's for real-time data as a stream, and it's not suitable for long-term data storage. So that concludes our lecture on big data, and I'll see you in the next lecture.